The recording. Okay, the recording is started now. Welcome everyone. Good evening. Everybody was late. I think it was Friday evening, so everybody was occupied. Let's start. We were on day three, but first things first. Notes creation. Day four. Yes, 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 yes. Okay, everything is fine. Is my voice clear? Let me just remove this charger also because we can create. Uh, wait. किसको? Okay, let's continue. So training day three. So we were on data yesterday, and we were on raids. So I will be continuing with raid first because there was a bit you can say there was some type of confusion in this also. Please tell me. Okay, I will be starting from the start, or should I? Or there are only specific. You can say RAID 0 error or RAID 1 error. Okay, no problem. I can show everyone with an example. Everyone will get clear understanding. RAID. Okay, I think there is a question. Beginning. Okay, sir. Sure, sir. Day 4. Wait. Day 4. So today we will be starting with the RAID. What are RAID? Firstly, let me start with the full form. Okay, so it stands for redundant array of independent disk. So what RAID was introduced? What was the motive to introduce RAID? So what basically RAID is? In RAID was introduced to achieve many type of goals. Like there was goal of, you can say, speed, to achieve more. You can say speed to achieve more data protection, to achieve more data recovery standards, or to achieve to protect your drives, to protect from disk failures. I will show you how this happens. Don't worry. So all the RAID levels are having different types of their functioning and different types of their pros and different types of cons. Like see, all only single disk can use fixed 100%, and RAID 0 can use 100%. Rest all are a bit low. But there are, where there is a pro, there is a con also attached to it. So we will be working on both of the aspects of RAIDs. So let's get started. Here's my document. Link.txt, new.txt, don't save. Hope the screen is clear and the voice is clear. So first is single disk. So what is single disk? Single disk are the disk we uses our at home. Like you are having a PC or a laptop at your home. So it will be a single disk. When it will get failed, your complete hard drive will get corrupted. Means if your device is damaged, you cannot use your device, you cannot get back your data till the device is recovered, or it is, you can say, bad sectors are removed. Bad sectors are the sectors that get damaged, so it can create failure in the hard drive also. So single disk is the single disk. Then RAID 0 came into effect. This is the first RAID level. So what RAID 0 do is, it is totally based on stripping. Okay, so have I given any type of link? No worries. So disk 0 stripping, disk 1 mirroring. We will be taking two RAID levels at a time because most of them are matching. Like if you are studying 1, you should know 0, and similarly 5 and 6 are connected. Similarly 1 plus 0 and 0 plus 1 are connected. So we will be understanding these RAID levels in three different parts. First is 0 and 1. Second will be 0 plus 1 and 1 plus 0. And third will be RAID 5 and RAID 6. So it will be very much easier for you to understand. You can understand it in a single go. So for RAID till RAID 0, oh sorry, for single disk you don't need any other type of other hardware. But when it comes to RAID 0, you will be needing at least two hard drives so that stripping can be enabled. What stripping is, you will be attaching data to two different hard drives. Let me show you with an example to give you clear understanding of what RAID 0 is happening. What is in RAID 0 happening? So it's brush. Okay, the size is good. So you are having two hard drives at your workplace. So what you do is, this is your laptop and you want to copy something in this and access it. So what you can do is, you can copy, paste everything here and then access it. And when this drives get full, what you can do is you can shift to another drive also. But in what happens in stripping, both the drives will get combined. So the data will be copy here also and here also, like both the device will act as a single device, so that the data is accessible at a very fast speed and the return speed is also increased, because our laptop can write on both of the hard drives at a single time and read also at the same time. So this is stripping. It is called RAID 0. Sorry if my handwriting is a bit bad, but my examples are very good. So this is how RAID 0 works. Both the hard drives will act as a single drive and our laptop can write on both of the drives at the same time. You can see uh, high input output rate. Input output means read and write. So you can see here it is good. Even in 3, 5, 6 it is only good, but in RAID 0 it is very good, just because of this thing, because you can access two drives at a single time. So hope you get understanding of RAID 0. Shall I come to RAID 1 now? If everybody got understanding how RAID 0 works. Okay, so let's wait. Everybody got understanding of RAID 0, or should I make you understand with a better example now again? Any yes or any type of no, so that I can continue, or okay, so I think everybody is clear with RAID 0. Save. Okay, now let's move forward to RAID 1. So RAID 0 was used to achieve maximum performance at that time. So then there was a time also where you don't need performance, but you need data availability, that your data should be available all the time. So there was introduction of RAID 1. So what happens in RAID 1 is, it is a very simple type of RAID. This is a laptop and you are having two hard drives. So what happens is you copy a data to a single drive, then the data is shifted to another drive. So this is why I was telling yesterday also, if anybody has noticed that you can use only 50% of the data, because the other 50% of the data will be used for copying of the first 50% of the data. Like you have copied a movie here, then the movie will be here also. So what is the main functionality of RAID 1 is, if your single device gets failed, like if your device is corrupted, or you can say any type of misconfiguration happens, or any type of mishappening happens, then you are having a true device that is having all the data you need, that is the exact same copy of the first drive. So then this drive can came in action and you will be having your data available at all the time. So the con with this type of RAID is that you can use only half of the drive, you cannot use full drive. So this was used to attain availability. And the RAID 0 was for what? Performance. Okay, 15 have joined, very nice. There are 14. So this is RAID 1. So now the part come RAID 0 plus 1 and RAID 1 plus 0. So so what, so you will be needing at least 4 drives for this type of RAIDs. Let me just show you with an example. This is RAID 0 plus 1. So what is happening here, you will be needing at least 4 drives with you. So let me take example of 4 drives. One drive, drive number 2, drive number 3, and drive number 4. So as 0 is written first, what will happen first? Stripping will happen first. So stripping between these two drives will happen first. Means both these devices will act as a single drive to achieve performance. PERFO dot. And similarly, these two drive will act for performance. Means they are the exact replica of these drive. So this combined is a single drive. What RAID 1 is? RAID 1 is all about mirroring. So this is the exact same mirror of RAID, sorry, of disk 1 and 2. So this will be equally performing well as 1 and 2, because stripping is in 3 and 4 also. It is obvious because 1 and 2 are having stripping, and this is the exact mirroring of the 1 and 2. So this is how RAID 0 plus 1 works. So hope you are clear with this example. Should I go to now 1 plus 0, or should I repeat again what is happening in this? Like you are having 4 drives and you want performance also, and you want availability also, that your data should be there all the time when you need it. So what you can do is, for achieving performance you can add stripping, and for availability what you can do is you can just mirror the drives. So you are having 2 drives. It can one more thing, stripping can also be done on many drives also at a single time. Like you can use 5 hard drives at a single time for stripping. Then the data will go through like RAID 0, open with paint. Oh my god, sorry. Okay, so if you are having oh sorry, 5 drives. Sorry, my tongue slipped. 3, 4, and 5. Here you are having 5 drives. So what you can do is you can make them all alike and all of them will work for your performance. Now I will show you how the performance will be achieved in these all drives. Suppose you are having a movie A. So what will happen in it will be divided into 5 parts. So it will be stored as A1, A2, A3, and similarly A4 and A5. So that's how stripping actually works. So as many drives are you are having, the more comfortable the performance will be. So you can attain as much as performance you want. You just need the configuration, hardware configuration, so that it can handle 5 drives, 10 drives, or even 20 drives. Repeat. Okay, sir. Which part that you didn't get? 0, 1, 1 plus 0, 0 plus 1. Dilshad, sir. 0 plus 1. Yes, I'm coming back to 0 plus 1. Nice, sir. So let's remove this. Cancel. I want a new one. Don't save. Okay. So now we are having correct posture. I'm taking example of 4 drives. But you can do is, okay, let me take example of 3 drives, so that it will be more convenient for you for further use. Like I have shown, where is my brush, like I have showed you the example of stripping. Suppose I am taking example of a movie, and the movie name is ABC. Okay, so you want performance and you want data availability both at the same time. So you will be needing equally, you can say, hardware that for mirroring also. Like if you have data for 3 drives, you will be needing 6 drives, because the data will be mirrored also. So how the data will be stored? In the first drive it will be ABC1, then it will be ABC2, then it will be ABC3. All these RAIDs are used where you will be needing a high disk storage, like in data centers, in big organizations, in labs, in you can say forensic labs, in cyber cells. There the actual, you can say, scenario of RAID comes, where you are using high disk storage, so you can attain anything you want, like you want availability, you want higher performance, whichever thing you want. So this is called stripping. Like all the device will be acting as a single drive, and your main laptop, main, you can say, hardware, whether it is a PC or laptop, can copy in all the files in all the hard drives at a single time. So now the mirroring will happen. The data gone for mirroring, and it will be gone to this. So what will happen here? They will create exact same replica of the first drive. ABC1, ABC2, ABC3. So this is the actual functioning of RAID 0 plus 1. Is there any doubt remaining? Please, you can come up with your doubt now with RAID 0 plus 1 if you didn't get now also. I got it, sir. Thanks very much. Now let's continue with the RAID 1 plus 0. So as the name suggests, it is RAID 1 plus 0. So 1 means mirroring and 0 means stripping. So let's take 4 drives. You can take many drives also that I have given example, and I can show you with more drives also if you want. No worries in that. So first mirroring will happen. So this will create exact same replica. Take the same example ABC as a movie, or it can be any type of file. I'm just taking example of movie. Here it will be ABC, and similarly here it will also be ABC. Here it will be BCD. Here also it will be BCD, and in between this stripping will be done. So basically what will be happening is, like, this is your laptop. Oh sorry, I should change the name of this. My brush DEF. DEF. Change the movie name also, DEF. Okay, so I'm done with my example. Suppose this is your laptop. I am writing it as p.c. So it is having you can say any type of movie or any type of data. Suppose it is having ABC. So it will divide your data ABC into parts. It can be ABC1 and ABC2. So that on first part, like there is ABCDEF. A B C D E F. So it will send first part to this side and the second part to this side. And what will happen here now? Here the mirroring will happen. Like if ABC is here, it will create another copy of ABC in mirroring. And similarly here also, if it is having DEF, it will send DEF here. So mirroring will happen on this side also, on disk 4. 1 2 3 4. And if you want example of ABC only, then ABC1 will be here and ABC2 will be here. I have taken example of ABCDEF so to make understand more easily. So you can take example of ABC1 and ABC2 also. But then the question will come, if I am having more drives, so how can I use? It is also very much easy. One more tree will be adjoined here, and you can name it as ABC3 or FGH, anything you want. So here also you will be wanting two disks, and similarly the mirroring will happen. So you can use any number of disks, n number of disks, and you can do RAID 1 plus 0 in that. Was there any problem in 1 plus 0? Is this thing needs repetition? Please answer with yes or no. Fine. Okay, now we have come to RAID STRIPPING plus MIRRO mirroring, and then 1 plus 0 will come as mirror and she. Hope it's clear till these four raids. Now raid 5 and raid 6 will come in action. These 6 type of raids are the most important raids that will be mainly useful to you. Your all basics will cleared with these raids, and only these raids are the, you can say, most highly useful or asked in the you can say anywhere, or you will be mostly working with. So this is raid 5 and this is raid 6. The main function of this is parity, and the main function of raid 6 is dual parity. Now it's a bit confusing. Let me just show you. But it was paint. Raid 5. So it is known for parity. P-A-R-I-T-Y. I'm sorry if my writing is a bit dull, but no worries. It's only for paint. You will be needing at least 3 discs for RAID 5. Let me take example of now hard drives. You have 3 hard drives and you will be needing at least 3. At least 3. And you can extend it to any number, and numbers are there. So what actually happens is you will be having data to store in these drives. So why RAID 5 was introduced? This is the main question. RAID 5 was introduced that even if a single drive fails, you will be having the data and without mirroring. So you will not be doing the mirroring, but you will be having the data with you. So how this thing works is it will creates a parity. Parity, in some words, they call parity as checksum also. Checksum is also, you can say, a type of parity. Uh, okay, now let's get started. So it is hard drives are divided into blocks. Let's start filling the data. A1, A2, and on this segment parity will be stored. Parity of block A. Shit, I should have taken bigger. I think I have enlarged too much. Let's see. Okay, so now it will be clear to understand. I am back with the big hard drives now. They are of 1 exabytes. If anybody don't know exabytes, petabytes. A, B, C. Okay. So in this part, A will be stored. In this part, A1 will be stored like we were doing in stripping. But on this part, parity. PA. parity of A would be stored. I am firstly showing you an example, then I will be showing you that how this parity works. Firstly, I am showing you how the data will be stored in RAID, and then I will show you the uses of this parity and why it is distributed like this. Parity block B, B1, parity 3, C, C1. Parity is not in a single drive. Parity is also distributed. The number of, you can say, the functions are you are having, like there are three functions, so there are three parity blocks. Like for A it is different, for B it is different, and for it is also different. So what actually is happening here is, let me remove this also. What actually happening is this is it is used for data availability. Yes, I have told you. So what actually happening in the background? So if you are having any two drives, you can gain access to third drive. Like if you are having, if any of your drive fails, suppose your one drive fails, drive two fails. I should name also them. It is one, it is two, it is three. Suppose your first drive fails, so both your 2 and 3 drive can work for recovering your first drive. So it can be very much helpful if you are having this RAID 5. uh, it is you can say similar to mirroring, but the thing is it is using parity and you will be needing a lot low space than mirroring. For mirroring you can use only 50%, but in RAID 5 and 6 you can use a greater, you can say, space. So this was the advanced version of mirroring. So what is happening here is, like, if there is A and A1, so there is parity of A. It is using an algorithm to create a value, so that if you are having any of these value, you can get the value of parity of A1. Like it, you can take example like sum. Okay, it is called checksum also. I'm giving example of addition. Like the algorithm is addition. So suppose in A 3 was there, and in A1 2 was there, and so in parity of A5 5 will be stored, because your algorithm says addition, it is addition. So similarly, take example of B and B1. Here it is 1 and here it is 2. So parity of B will be 3. Take here, oh sorry, take here 2 and take here also 2. So what will happen here? It will be around 4. So hope you understand. This is the basic. Now I will show you the demo how you can recover the data if your single drives get failed. So suppose if your drive 1 gets failed. So now you are having something like that, something like this, empty blocks like this. So you have drive 2 and you have drive 3. So you know that addition was there. So what you can perform is you can perform uh, subtraction. So you know where is parity stored. So you can just take the parity and you can reverse engineer the you can use reverse engineering of the, you can say, this algorithm. So if you reverse addition, subtraction will be there. So if you subtract parity of A from A2, then you can get the answer easily, that is 3. So now in similarly here is B1. So B1, you don't have B1. So what you can do is you can take the parity of B and you can subtract it from parity, or sorry, from B1. So 3 minus 2, it will be 1. 3 minus 2, it will be 1. So parity of 3 is also missing. You don't even need parity of 3 because the data is stored in C1 and C2. But still you should, you can say, have the data of parity of C3, because it will be beneficial for you, because you can use it for further also if your drives get failed. Like C1 and C2 are there, you can calculate their parity by just adding, because you will not be using subtraction, because parity is not there, data is there. C1 is also data and C2 is also data. So any doubt in this, that how the things are happening? You can do it same way with drive 2 and drive 3 also. Like, wait a second, if you are not having drive, which example should I take? Should I delete drive 2, drive 3, or it is clear? Please come up in the comments. In RAID 5, if we have 1 TB, 3 HDD, then how much space of storage? It will be around, if I'm not, I haven't calculated that how much space will be required. Oh, sorry, how much space we can use. You can take an example. If you are having 3 drives, and so total will be 3 terabits. So you can use approx. You can say around more than 2 gigs. Oh, sorry, more than 2 terabytes, because it will be storing only checksums. It will definitely more than 1.5, because moderate was there in 1.5, and it will be definitely good in RAID 5. So it will be around, I think, more than 2, definitely more than 2, no doubt in that. Any more? Please tell if it is clear, or should I delete one more drive, suppose drive 2 or drive 3, or should I continue with RAID 6? Any answer? RAID 6 or drive 2 or drive 3, or clear or not, anything? RAID 6. Okay. Hope my example was very much clear to you, that how recovering can happen in RAID and how RAID 5 works. Save. Let's continue to RAID 6. Oh, sorry, I have written here RAID 6. Oh god. Okay, we are starting with RAID 6 now. What is the main function of RAID 6? This is the main function of RAID 6, why RAID 6 is achieved. Uh, Eraser. I have taken 4 drives. 1, 2, 3, 4. Okay, so you will be needing at least 4 drives. Eraser. Just please comment how many drives should I take. The minimum is 4. I can take 4 or 5. Minimum. MIN. Minimum 4. The minimum is 4, and I can show you an example of 5. Okay, so I should start with 4 drives only. 1, 2, 3, 4. I'm waiting for your replies. No worries. I will be starting with this line. It is a bit complex, so I'm simplifying the diagrams so it will be easier for you all to have an understanding of the functioning of RAID 6. Be careful with this one because it is a bit complex than all you have read it till now. Where the cursor is. Okay. So I am writing parity as P dot A. Okay, so I'm almost done with the data storage. Just I have to fill now parity blocks. So here you can see 4 drives are there, and A1 and A2 are also there. So what will happen in this thing? They are having 2 parity blocks each to store the parity of each blocks twice. So what can happen is, okay, don't worry. So if even 2 drives fail, so what is the purpose of this RAID 6? Even if 2 drives fail, your data will be secured. Even if we delete any 2 of the drives, your data will be there with us, and you can extract your complete data without even losing any of your data. So this is how it works. Let me first fill up the parity blocks. it will be, I think, a dot 2, and it will be here exactly the same, a dot 2, a dot 2 star. Then coming here, so it will be having around b b. Yes, it will be having b and 2, b2 star. Similarly, c1 and c2 and c2 star. Similarly, this d1 and d2 star. If you are good in maths in your elementary classes up to class 12, you will easily be knowing to this, that how to calculate the values of x and y if there are four algorithms, or sorry, if there are four equations. So how this works is, firstly there is a checksum of a1 and a2. Here is the checksum of this, like I have told you in the previous. And in this, the combination checksum of this a1 dot 2, a1, sorry, a1, a2, and parity of a2 is stored in p dot a dot 2 star. And similarly, in of parity, oh sorry, of b1, b2, the parity is stored in p, oh sorry, parity of b2. And one there is a combination of all three, like b1, b2, and parity of b2. It will be stored in parity of b2 star. For example, abc abc1 is there, abc2 is there. It is nothing, eraser. abc1 is there, abc2 is there, so it will be equal to parity of abc. And if you add this also, it will become abc1 plus abc2 plus parity of abc equals to abc, sorry, p dot a. It will become parity of abc star. So recovering is also very much easy. Like if any two of the drives are missing, let's suppose, where is my pen? Okay, so I am naming them as 1 2 3 4. 1 2 3 and 4. Suppose you are having these four blocks, and you know ABC is data, ABC2 is data, and parity of ABC, you know, it is the you can say a checksum of ABC1 and ABC2, and ABC star is the checksum of all these three combined. So I will be showing you with an example by deleting all fours by any two by single time. So suppose 1 and 2 are deleted first. So this is deleted, this is deleted. So now you will be left with parity of 3 and 4. So what you can do is, firstly you will be subtracting this from this. So what you will be getting is ABC1. By having 1, you will be having the data of, okay, sorry, by just subtracting, you will be having the complete data of ABC1 and ABC2. Wait, let me just give them values. it is having value 1, it is also having value 1. So what it will be having? It will be having value of 2. So now what it will be having? It will be having value of 4. So you have this value and this value. So what you can do is you can just subtract d4 and d3 and you will get your result. 4 minus 2, it will be 2. And exactly you will be getting the result. The result is abc1 plus abc2, and this is 1 plus 1, 2. I am just taking it as a sum, but in real life scenario, it is not sum. It is the big algorithm which is calculating checksum, which is very much you can say efficient, and it can really get you the data back. So it is just an example. Like if you are having 2 and 3, and you are not having 1 and 4, so you can get out the data. And similarly, if you are having 3 and others also, so you can get the data even if you are having not having two of the drives. So let's in row 6 we have 1 TB. Sir, similarly like RAID 5, but it will be having a less space, because like in RAID 5 you have seen like it was storing a single parity block, but now in each drive it is saving two parity blocks, so it will be having less data. So you can compare it like if there was around 80% data in RAID 5, then RAID 6 will be around 70% data, because there are two parity blocks. Not exactly the same ratios, but somewhat around like this. You can divide it with around 75, like RAID 5 will be more than 75 and RAID 6 will be less than 75, to be more precise. Shall we come with the hex editor, because today only RAID is taken and I don't. Okay, let's just get to the data deletion more quickly. Where's today's training? Today's training was a lot of time consuming, I know, but RAID was also very much important, as it was I think your most favorable topic. So let's get directly on the data deletion. What data deletion is, how the data deletion will work, and how all this thing works. RAID 6. Please come up with your doubts. Don't worry. Today we will be extending some time, because the class was started late because there were no participants in the starting. Hex editor. So let me just clear your doubt with hex editor. What is hex editor? What is its work process, and what is this thing HXD? And there is one of my favorite software, Hex Editor Neo. So you can download Hex HXD and Hex Editor Neo also. What this new thing works, it provides you many automated tools. So REST HXD is totally manual, but Hex Editor Neo is an automated based. So you can get to know what actually is happening in the background. So what is its work? Hex editor, as the name suggests, it can edit the hex values. So there is hex viewer also. You will be needing hex viewer only, but you can use hex editor also, because it will be having definitely a large number of functions, and you can say applications, or you can say uses. So what is the process? As you all know, the computer uses the language of 0 and 1. So what it reads the same data that the computer will be understanding. So like here is my image. I open with it Hex Editor Neo. So you can see how my image look like. So you will never be able to understand that what this type of data is. You can see the values F5 139580, uh, th this is very much difficult even to understand that what this thing is. But here you can see some of the things like ADAOBE dot Photoshop CS6. So what this means is it is created by Adobe Photoshop CS6 Windows. It is the timestamp. You can get the timestamp. So this is why hex editor is very much important. Like I am showing you the example. Like this, which image this was? Okay, rename JPG MP4 dot MP4. So here a notification has came. If you change the file extension, this file might become unusable. Are you sure you want to change it? Yes. Suppose I want to. Okay, this is in use. Let me close this first. So many time what will happen while recovering data is the file extension will get deleted and you will not be able to find which extension it is using. So you can open it with hex editor and sometime you can have the direct view of that which type of thing it is. Like if you know which software or what is Photoshop. Wait a second, just give me a second. There's a message. Okay. Okay, so you will be knowing that if you know the software, you can know that Adobe Photoshop is a software for pics and it is definitely a pic. So you can just change the name again to JPG to, you can say, access it if the extension is deleted. So it is very much easy to know the extension. Even if there is no data available here, I think I have pasted the site. Okay, let's visit this site. What this site says. Okay, so there are a lot of, you can say, these are the hex values, these are their formats, and these are their extensions. And this is the description of their, you can say, extensions. Like JPG will be having, well, let just go to JPG. Okay, so it is having a raw or image or exe file format. So you can say something is written here, y, and these symbols are there. So let's open that file. Where was that file? Okay. Okay, so now can you notice something? Is something noticeable to you? Is it looks like similar or not? Even if it is not there, you can just go with these hex values. Just take this FFD8 FFE0 and come up here. FFD8 FFE1 and all the things. Now let's go to the end of the file. Okay, it's ending with D9. Okay, it's a correct file. So this is how you can find out the file format. Even if you have recovered the data and you don't know which extension it is, you can go with hex viewer or hex editor. By hex viewer and hex editor you will be able to gain the hex values of the image, that how the computer is understanding that file. And by using the computer understanding you can get to know that what file format it is, and by changing the file format you can definitely access the file. So this is the use of hex editor, and it can definitely change your file also. See, I am having a file in Notepad. It is of 0 bytes. This is the file. When I go to edit, and there are very much there are large functions in hex editor new, as I have suggested you. Change file size. You can say it's in bytes, KB, MB, GB. I want to make it of 1 gig. I will just type here 1. Okay. So now you can see 0 0 are written everywhere in my file and a large number of zeros are written. because it has extended the file to 1 gigabyte. Let me just store it. It is making my file. It is changing the hex values of see, my file is now changed to 1 gigabit, and you can change your file to as much big as you want by changing the hex values. So this is how you can play with the hex values. You can even change the insider data also if you know how to play with the hex values. So this was the example of hex values. Anybody has any type of doubt in hex values? So now we can start with data deletion. I can complete 1 2 slides of data deletion also. Then we saved on save, saved on save. Okay, what is, yeah, save, no worries. Any type of question? Did everybody get to know how the hex values work, how hex editor works? So let's continue with the topic of deletion. I know the notes are not done of hex values. We will be clearing that tomorrow. Topic is today data deletion. What is the data deletion process? These will be the topics to be covered. What happens to the data? Different methods of deletion. So let's start with the data deletion process. What actually is data deletion? Okay, we will cover it later because I have a beautiful slide with this slide. We will be covering it. Firstly, let's see what our recycle bin is doing. So this is the basic thing of deleting file. In Linux there is trash, and in Windows there is recycle bin. File deletion is a way of removing the file from computer's file system. The reasons for deleting files are freeing up the space, removing duplicate, making sensitive information unavailable to others. Okay, this is the method I used to do in my young age. Users can delete files in several different ways. Files are moved to recycle bin in the following ways: by right clicking. Okay, this is the very much basic format that you just click on delete and it will be shifted to recycle bin. One more important thing, if you are using external drive, like if you are using hard drive or USB stick, and if you delete the data from that, it will not go to recycle bin, it will be directly deleted. So keep that in mind before deleting anything from your external devices. What I have given in this slide: deleting NTFS files. On deleting Windows Explorer for recycle bin, command prompt recycle bin was found as only recovered from forensic tools. Okay, yes, on deletion from Windows Explorer, the file is moved to the yes. If you delete it from using the CMD process, it will be directly deleted, and then you have to use the forensic tools or the automated tools that I have shown you. They give an examples of the practical will also be taken. When a file is deleted, the operating system performs the below task. Okay, so these are the tasks that are done. Clusters are made available for the new data. Okay, let's give you a simple example of how file deletion works. Is my paint size okay? Okay, deletion. So how this process works is uh, okay, let me give an example of a book. Here is book, here is chapter 1, chapter 2, and chapter 3. I am not giving you example of recycle bin. I'm showing you the process of deletion. What happens in deletion? Normal deletion, when the file is moved to directly deleted. So what will happen in that process? It will not apply for recycle bin. I will show you the process of recycle bin, I think tomorrow, with an example. So it will work on, I think, on all type of, you can say, your external disk, and for recycle bin also, if you are empty your recycle bin. So this process will be followed. Like there are your chapters in book, it is named as ch1, ch2, ch3. So your book is having three big chapters. Like chapter 1 is there. Suppose it as a file. Don't take it as a book. Take it as a file, pinned file, where you can take out the documents and take in the new documents, because in book you cannot add the new pages. So take it as a file. uh, so in a file there are three chapters: chapter 1, chapter 2, and chapter 3. So you have completed chapter 2 several times, and it is occupying a lot of space. Or there can be any of the chances that I have already told you in the my slide. There can be data deletion also. There can be a file securing method also, and unnecessary files also, and used files also. The thing is, you just want to delete that files. Like if chapter 2 is very much unuseful, and it is you can say completed or something, you can be also be the reason for deleting a file. So chapter 2 is done and you want to delete it. So what you will be doing is, you will be going to chapter 2, ch2. You will be taking out all the papers, ch2, and you will be just taking it on a side. You will be taking out chapter, if you want. Okay, sorry, it was really a bad example. uh, Let me just show you. So what you will be doing is, they are having numbers like this. Chapter 1 is I just messed everything. Don't save. Deletion. I just mixed the two process. Sorry if the spelling is wrong. I'm not concentrated on this thing. This is a book. This is the separation of book. Here is chapter 1, and it is from page 1 to 10. Here is chapter 2. It is from 10 to 20. Here is chapter 3, and all these chapters are digitally assigned. It is 20 to 30. So it is a book. Suppose it as a book, and the ink used is reusable ink. Like you can remove the ink whenever you want. So you want to delete chapter 2. So what you can do is, you just can remove this part. If you just remove this part, 10 pages will be vacant in your file. Like you just remove this with the ink on the index. You don't have removed from inside. You just have you can say, for your easiness, you just have removed it from the index of your book. So what will happen, the data will be there, but your index will be showing it, the data is available. So whenever there will be a new addition of data, it will check whether the space is available or not. So it will come to your index. It will ask, index is data available. So it will say yes, 10 pages are available with me. So while writing the next new 10 pages, what it will be do, it will just overwrite the data. While overwriting, the previous data will get damaged, or you can say overwritten. You also every I think everybody know how this thing works. Like new text document. This file is too large. Okay, this is 1 gig file. Delete. New new text document. I'm renaming it as testing. testing. Okay, it's testing. Shit. It's test. So I am showing you how overwriting gets in action in your computers. I am typing here testing. Suppose this was your chapter 2, and it was a saved chapter. Like you can see, the chapter is saved. So now this is of no use. So now what index will do is index will delete this file, the inside of this file. Nothing will be done. It will only show, okay, this file is empty and this is having testing, so I just have to change the name of testing to test. Sorry. Okay, so the name is text.txt, and similar with here test.txt, but this file is empty. So if I paste this file here, it will ask replace this file in this destination, means overwrite the file, skip this file, means don't do this, and compare info of both files. If I do compare info of both files, here it is 0 bytes and 7 bytes. In 7 bytes testing is written, in 0 bytes nothing is written. So if I do continue, the data will get overwritten. Now you can see there is no data. So this is how overwriting works. Paint. So the new 10 pages will be overwritten on the previous data. So the previous data will automatically get deleted when the new data will came and get overwritten on this. So this is how deletion works in background. I will be showing the practicals and each and every scenario tomorrow. Mm, save, save. Let's come up with your doubts now.